Hi, welcome to part 2 of arc trigs and integration. If we look at our problem right here, I'm going to try use substitution. I can do this in my head, and I know it's not going to work because 2x minus 4 won't cancel with anything. So we get a little creative. Now, because use substitution fails, we have to use our arc trig functions because they're the only ones we know right now. And because this has no square roots, this looks like it's going to be an arc tangent. Now, to make this arc tangent, remember, arc tangent says this. It's du over a squared plus u squared. Well, that looks nothing like that. But what we can do is use complete the square. And that's what we're going to do here. And it's very easy to do. If I rewrite out the top, now the bottom, to complete the square, I'm going to separate that one in terms of my x's and leave the 7 on the outside. And I get this x squared minus 4x plus some blank. I'm going to be adding something to it. And I still have that plus 7 on the outside here. To complete the square, we take half of negative 4, which is negative 2, squared, so I'm adding 4. I have to balance out the equation, so I subtract 4 as well. Remember, that's to balance it out. I can do whatever I want to an equation as long as I undo it. So if I add 4, I just take away 4. And you may think, why would we do that? Well, let's take a look at what happens. We get this, dx over, this becomes x minus 2 squared plus 3. And now we're starting to look more like our formula for arc tangent. The only difference is we have to switch the a and the u. So I'm going to rewrite this as dx over 3 plus x minus 2 squared. And here's our a, so we know a squared is 3, so a is root 3. U squared is x minus 2 squared, so u is just x minus 2. Again, I want to take the derivative just to see if I'm going to wind up dividing my answer by anything. So there we have everything. So this is our arc tangent. Remember arc tangent, right? It's 1 over a arc tangent u over a plus c1. So our answer, 1 over root 3 times the arc tangent of x minus 2 over root 3 plus c1. And there's our antiderivative. So let's take a look at another one of these. Same type of problem. What about the antiderivative if we do like something like dx over the square root of negative x squared plus 6x? Well, now again, use substitution won't work, so we can only use our arc tangent. And because there is a square root, this is either arc secant or arc sine. Nothing on the outside, so probably arc sine. So to get this in terms of arc sine, again, we're going to complete the square here. This is a little bit harder to do, so see if you can follow along. Long square root symbol, you'll see why. I'm going to factor out the negative, and I get this x squared minus 6x. I'm going to start to complete the square process, so I put a plus a blank. On the outside, there's nothing here. So I can put plus 0. You don't put down anything if you don't want. Okay, it's okay. But, it doesn't bother us. Now, when I complete the square, you complete me. I take half of negative 6, which is negative 3, and I square it. I get 9. Now, I have to undo it. We would think I'd have to subtract 9. We would think that. But remember, we factored out that negative in the beginning, so that's really a minus 9. So we have to add it to undo it. Okay, there we go. And now I can write this in the correct form. This is the square root of negative x minus 3 squared plus 9. Now remember, arc sine was really du over the square root of a squared minus u squared. So again, I'm just going to rewrite this. Dx over, if I write this out now, integral, the square root of 9 minus x minus 3 squared. So a squared is 9, getting ahead of myself. U squared is this x minus 3 squared. A is 3, u is x minus 3, so du is dx. Again, I want to check this because what if I had a number right there? I'd have to divide, right? I'm going to have to go on with the fraction on the outside. And then our answer, remember arc sine is the arc sine of u over a plus c1. So I get arc sine x minus 3 over 3 plus c1. And there's your answer. Whoops, arc sine, can't spell arc. You know what? I'm going to rewrite it because I want to make it look pretty for you. Arc sine of x minus 3 over 3 plus c1. There we go. Darn my ability to not write nice. Okay, now let's take a look at another one here. Okay, we're going to take a look at a couple more examples. And we're going to see just kind of like what we can do with these, because sometimes these can get a little bit more challenging. Alright, so like this next one. Okay, let's see here. The antiderivative of x plus 2, whoops, let me see if I can get that refocus here. The antiderivative of x plus 2 over the square root of 4 minus x squared dx. Now here's kind of the neat thing about this one. It's actually kind of a cool thing because one, if I did use substitution, I get 2x. Now that x will cancel if I just had the x there. So I could use substitution for if I just had the x on top. But on the other hand, because x plus 2, use substitution fails. Oh no! What do we do? Well, let's take a look. If I had without the x and just the 2, that's my arc sine. So I actually have two problems here. I have a use substitution and an arc sine. So how do we do a problem like this one? Well, we did a problem like this earlier this year. You might remember if we did something like x squared plus 3 over x dx, we would split the fraction because I have a common denominator. And that's exactly what we're going to do here. I have a common denominator. So I'm going to split the fraction. And I can rewrite this as x over the square root of 4 minus x squared dx plus 2 over the square root of 4 minus x squared dx. I can split my fraction, just like we can split an atom. Not as detrimental to our health, though. Now, when I split it, I have two separate integrals. I have to solve them two separate ways. Over here, this is our use substitution. And we can do that pretty quickly. U is 4 minus x squared. Du is negative 2x. Dx equals du over negative 2x. And I'm going to substitute in here really quickly. This becomes negative 1/2 times the antiderivative. X's will cancel. And I'm left with u on the u to the 1/2 on bottom. So if I bring it up, u to the negative 1/2 du. So convince yourself that that's right. I do all the time. Plus, now over here, this is my arc sine. So I know a squared is 4, u squared is x squared. A is 2, u is x, du is dx. And what's really kind of cool here, I can go straight to my answer. Arc trigs are actually kind of easier than use substitution, if you notice. This is plus the arc sine of u over a, x over 2, plus c1. Now, I'm not finished because I still haven't taken this antiderivative. This becomes negative 1/2 times, add 1, 2u to the 1/2, plus the arc sine of x over 2 plus c1. Don't take the antiderivative again here. We're done here. We're done with the arc sine one. And I just replace my u. This becomes negative, and u is, because the 2's cancel, 4 minus x squared to the 1/2 plus the arc sine of x over 2 plus c1. And there's our full antiderivative. So we can do kind of cool things with these. A lot of people tend to like these. They like little puzzles. What can I do? All right, now our last one. May God have mercy on your soul. Let's take a look here at the last one. 2x plus 5 over x squared plus 8x plus 25 dx. Now this one we have to get creative because it's almost like the last one, except where it's not a common denominator, so that fails for us. Wow, hello. So what do we do for a problem like this one? Well, let's try use substitution. I let u equal, of course, the bottom, x squared plus 8x plus 25. Du is 2x plus 8. dx. Oh my gosh. Do you see this? I was told I needed to dance more, so here we go. Do you see this one? Look at this. Right here. That 2x minus 8. That 2x plus 8. Sorry about that. Let me focus in here. You can't see it, but I can. That 2x plus 8. It is almost the same as this 2x plus 5. In fact, if 2x plus 8 was a 2x plus 5, we could use substitution. So you know what we're going to do? We're going to cheat. That's right. We're going to cheat. Not really cheat. Let's do an algebra trick. Remember what I told you. You can do whatever you want. So what I'm going to do on the top here is I'm going to make this 2x plus 5 a 2x plus 8. Sorry, the other way around. It's a 2x plus 5 with a 2x plus 8. Sorry about that. Got excited about my dance. So what we're going to do is we're going to make this 2x plus 5 an 8 by adding 3 to it. But I changed the value of the function. So I undo it by subtracting 3. Because I have to undo what I did. I can do whatever I want. I added 3. I just take away 3. It doesn't change the value. I can do it. But watch what we're allowed to do now. This becomes x squared plus 8x plus 25 dx. And we get 2x plus 8 minus 3 over this x squared plus 8x plus 25 dx. Now, what I want to point out is we now have a u substitution right here. There's my u substitution. So I'm going to rewrite this one. 2x plus 8 over x squared plus 8x plus 25 dx. I got my u substitution. That's what I wanted. But it came at a cost. This 3. My u sub cost me this extra 3. But that's easy enough to do. I can just write another integral for the 3. 3 over x squared plus 8x plus 25 dx. So now I have my u sub, which is what I wanted. So let's deal with that first. Then we'll come back to this one. My u I know is x squared plus 8x plus 25. My du is 2x plus 8 dx. So dx du over 2x plus 8. Now what's cool is I know what's going to happen. Those are going to cancel. I made it happen. That's why we chose those. So we're left with the antiderivative of 1 over u du. And we know that. So let's go back over here now. Over here, this is going to be our, oh my gosh, this is going to be our arc sine. But remember, it's not arc sine yet, so we have to complete the square. So let's go ahead and complete the square here. Easy enough. So you get minus 3 over x squared plus 8x plus a blank plus 25. So this becomes what? Half of 8 is 4. Add 16. So I subtract 16 to balance it out. And now we get this integral. 3 over, and remember, switch it around if you need to. 25 minus 16 is 9 plus x plus 4 squared dx. And now I can just integrate them. This is easy. This is just a natural log of u, which we said earlier was x squared plus 8x plus 25, minus, this is our arc sine, where we know, well, don't forget the 3. We have a 3 here. So we got a squared is 9, so a is 3. U squared is x plus 4 squared. U is x plus 4. Du is dx, just checking. This becomes times 1/3, 1 over a, arc, I'm sorry, not arc sine, that's arc tangent. Oh my gosh, please, that's arc tangent, not arc sine. So you get 1/3 arc tangent of u, x plus 4 over a, 3 plus c1. And there's your answer. And of course you can eliminate those. Again, forgive me, that is arc tangent, not arc sine. I will not ever admit to making that mistake again. So, and there's a final answer. A little bit harder. So these do get more challenging, so good luck. Bye-bye.